Greetings. My name is Anatoliy. I'm a PhD student in system analysis at Zaporizhia Polytechnic National University, and I will briefly present the work of our group on the methodology for building access control systems based on fuzzy logic. What the main problem? The size and scope of IT infrastructure usage are growing, and the number of economic processes supported by computing servers and software is also increasing. The modern large IT structures uh, uh, have a variety of technical, methodological, or comprehensive solutions what can be used to implement effective access control. However, the diversity of platforms and tools used, as well as the multitude of influencing factors, significantly reduce the effectiveness of access control and increase the risk of cyber threats. What I will propose? Our work aims to improve the efficiency of managing the access control system components or of IT infrastructures by developing a methodology that combines modern tools and methods for analyzing data in states of information systems to determine the risk level of the access control system. Our specific objectives: develop the methodology, demonstrate the framework and how it will function for access control systems, conduct a pilot mathematical experiment, and draw conclusions on the benefits of this methodology and identify the next steps needed to address the main issue of access control systems. The main points of methodology divide the given IT structure into subject and object, evaluate them based on risk significant factors, establish the values and levels of those factors, ranging from 3 to 5 levels according to standards, define the rules of interaction with the help of experts specific to the structure, and perform calculations using fuzzy logic as the factors have impressive values. Obtain an overall risk assessment for the granted access based on which decisions can be made to improve the systems. So how the methodology will work? The entire IT structure will be divided into subjects, users, and objects services to which access is granted within the framework of the existing access policies in the structure. Data for the factors will be collected using widely used IT infrastructure monitoring and management tools. We also use databases and libraries for IT infrastructure management and cybersecurity enhancement, such as CVE and SCAP, to help establish factors, establish factor values and some interaction rules. And we perform calculation using fuzzy logic to obtain a risk assessment for the granted access. The basic set and the interaction of factors. We measure the subject using the level of password and authentication, which is grouped into the access management level indicator. Next, we describe the object in terms of how frequently it's needed, the sensitivity of its information, and its interdependence with our objectives. We also describe the object, its interaction with subject, considering potential interactions and its local network with factors such as the level of access privilege. The subject has to the object the type of network, its level of openness, and the potentially possible attack vector. Considering the exploit majority, overall those factors are grouped into two, attack likelihood and attack severity level. The combination of those factors provide us with the access control system risk level. Also, anomalous behavior of the subject and object may be considered to assess the risk dynamically. About experiment. They conduct simulation testing to understand a limited number of factors to verify the logic of factor interactions and to evaluate the use of the methodology. Here we present a set and a simplified interaction scheme of the aforementioned factors within the experiment framework, ultimately resulting in the same risk assessment for the granted access. This is an example of a set of linguistic variables and outputs for risk assessment. Additionally, it includes examples for some rules established by experts during the experiment based on their knowledge and the standards which were used for calculation in MATLAB. As a result, we obtain the risk level fuzzy output, which essentially shows us the potential risk levels within an access control system based on different combinations of access management and password management settings, as well as access levels and privilege risks. It provides a visual representation of how risk levels change with varying inputs, helping to identify which combinations may lead to higher or lower security risks. Also, the surface allows administrators to predict and understand the impact of different security configurations and make informed decisions to optimize the security of the system. So what conclusions we have? By combining modern network control tools, up-to-date vulnerability libraries, and comprehensive analysis of IT infrastructure data with the application of fuzzy logic, we achieve a more objective and effective risk assessment. This combination is superior to other existing approaches and methodologies or analyzes that lack any of those components. The test results of the proposed methodology can help improve the applied access policies and the access control system itself, including the human-machine level. About further research, what options we have? Enhanced risk assessment integrates advanced tools and fuzzy logic for improved risk evaluation. System improvements applies test of fundings to optimize access control systems, adaptability and AI development, of course, focuses on adapting methodologies focuses on adapting methodologies for the diverse IT infrastructures and developing AI tools for dynamic system monitoring and expanding metrics. Explores using a broader set of indicators to assess IT structures per international standards. For details on the work and results, please refer to the article of the same name. Contacts for issues or partnerships can be found on the last slide. And thank you for your time.